Hello everyone and welcome to this video on numbers. In this video we will see the different categories in which the numbers are classified and then we will discuss in detail about prime numbers. Let us begin. Numbers are broadly classified into two types, real numbers and imaginary numbers. All the numbers that you can represent on a number line will be classified under real numbers. So suppose if this is your number line with 0 at the center, plus infinity to the extreme right, minus infinity to the extreme left. So the numbers such as 1, 2, square root 2, 0.5 and so on up till infinity. Even on the left hand side of the 0, minus 1, minus 2, minus 0.33, minus 100. All these numbers will be classified under real numbers. Whereas all the numbers that you cannot represent on a number line will be classified under imaginary numbers. Imaginary numbers are basically square root of negative numbers. For example, square root of minus 3. You cannot represent this number on a number line. Hence, it will be classified under imaginary numbers. Square root of minus 100. This also will be classified under imaginary numbers. So, how do we represent an imaginary number? In this, what we will do, we will separate the positive part and negative part. So, this can be written as minus 1 into square root of minus 100, square root of 100. This square root of 100, as we know, is 10. Square root of minus 1 is represented by the letter I. So this square root of minus 100 will be nothing but 10i, where the value of I is square root of minus 1. Hence all your imaginary numbers will consist of a letter I. So any number where you see the letter I will be classified under imaginary numbers. Real numbers are further classified into two types, integers and decimals. Let us first understand what is a decimal number. If you consider this fraction 1 by 2, we can write this as 0.5. As you can see, this number consists of two parts. The whole part, which is 0, and the fractional part, which is 5. The whole part and the fractional part are separated by a dot, which is known as decimal. Okay, so all the numbers that consist of this dot or the decimal will be classified under decimal numbers. For example, 0.33, 0.25, 0.96, 1.96, 2.87. So all these numbers which consist of a decimal point will be classified under decimal numbers. On the other hand, the integer numbers do not consist of a decimal point. Example 1, 10, 20, minus 100 and so on. So these numbers do not consist of decimal point. They will be classified under integers. Decimal numbers are further classified into two categories, finite numbers and infinite decimals. So what are finite decimals? The decimals which are terminating in nature. So 0.5, 0.25, these are the examples of finite decimals. Whereas infinite decimals are non-terminating. Example 1 by 3, its value is 0.33333. It goes on till infinity. It does not terminate. So these are the two categories in which decimals are classified, finite and infinite. Infinite decimals are further classified into two types, that is recurring and non-recurring. As we have seen in this example, 0.33333, the number 3 is repeating itself. After the decimal point, the number 3 is repeating itself. Hence, it will be classified under the category of recurring decimal. For non-recurring decimals, the digits to the right of the decimal do not repeat in a fixed pattern. Example, square root 2, square root 3, the value of pi, which is 22 by 7. If you convert it into decimals, it will be 3.143 something. So it does not repeat in a fixed pattern. These numbers are classified under non-recurring decimals. Let us now see how the integers are classified. Integers are classified into three types, positive integers, negative integers, and 0. Remember, 0 is neither positive nor negative. These positive integers are also called as natural numbers. So all the numbers from 1, 2 up till plus infinity are called natural numbers. All the numbers to the left of 0, minus 1, minus 2 up till minus infinity are negative integers. These positive integers are further classified into three categories: prime numbers, composite number, and unity. One is neither prime nor composite. So what is a prime number? Any number that is divisible by only 1 and itself is called as a prime number. Example 13. 13 is divisible only by 1 and 13. 17, then 23, 43. So all these numbers which are divisible by only 1 and itself are classified under prime numbers. Whereas all the numbers other than prime and unity are classified under composite numbers. 2, 20, 100. So all the numbers which are neither prime nor 1 are classified under composite numbers. One more important thing, as I have said previously, that positive integers are also called as natural numbers. If to this natural number we also add 0, then this set of numbers will be called as whole numbers. Positive integers, which are natural numbers, plus 0 are called as whole numbers. So this is how the numbers are classified under different categories. I hope you were able to understand this concept. Let us now discuss in detail about prime numbers. As I have said previously, all the numbers which are divisible by 1 and itself are called as prime numbers. The examples are 2, 3, 5, 7, 11, 13, and so on. All these numbers are only divisible by 1 and itself. So, how do we identify whether a number is a prime number or not? For that, we will follow the following procedure. We will take the square root of the number and round it off to the next higher integer value. Let us consider, for example, the number 37. If you want to check whether this number is a prime number or not, we will take the square root of this number and round it off to the next higher integer. So square root of 37 will be 6 point something. We will approximately round it off to 7. Now what we will do is, we will check for divisibility of this number by all the prime numbers less than this integer value. So what are the prime numbers which are less than 7? 2, 3, and 5. These are the three prime numbers which are less than 7. So we'll check the divisibility of the original number, which is 37, by 2, 3, 5, and 2, 3, and 5. So if 37 is divisible by any of these three numbers, it will not be a prime number. If it is not divisible by any of these three numbers, it will be a prime number. So clearly 37 is an odd number, hence it is not divisible by 2. If we check for divisibility by 3, again it is not divisible by 3. For 5 also it is not divisible by 5. So we can say, yes, 37 is a prime number. If you want to take another example, let's say 127. We'll take the square root of 127. It will be 11 square is 121. So it will be 11 point something. We'll round it off to the next higher integer, which will be 12. Now what are the prime numbers which are less than 12? 2, 3, 5, 7, and 11. Now we'll check the divisibility of this number 27 by all these numbers. Clearly it is not divisible by 2. And again, if we take the sum of these digits, it is coming out to be 10. Again, it is not divisible by 3. Clearly not divisible by 5. For 7, if we see 7 1s are 7, we have 5 carry 7, 8 is 56. So again, it is not divisible by 7 as well. For 11 also, it is not divisible by 11. Hence 127 is a prime number. Likewise, if I take, let's say, 57, the square root of 57 will be 7 point something. So next higher integer is 8. What are all the prime numbers less than it? 2, 3, 5, and 7. Let's check for divisibility of 57 by all of these numbers. Clearly it is an odd number, hence not divisible by 2. And yes, it is divisible by 3, hence it is not a prime number. So in this way, you can sure tell whether a number is a prime number or not. Now sometimes we don't really need to follow this procedure. We can eliminate using some techniques. If you have noticed, all the prime numbers will always end in either 1, 3, 7, or 9. So if a number is not ending in 1, 3, 7, or 9, then it is definitely not a prime number. If it is ending in 1, 3, 7, or 9, it can be a prime number. So if you see any number which is not ending in 1, 3, 7 and 9, you can straight away say that this number is not a prime number. If the number is ending in 1, 3, 7 and 9, then you will have to check using this method and conclude whether the number is a prime number or not. Another check that you can do for eliminating the option is that all the prime numbers are expressed in the form of 6k plus or minus 1. That means all the prime numbers are 1 less or 1 more than a multiple of 6. So if a number is not of the form 6k plus or minus 1, then it is definitely not a prime number. So by these two techniques, you can eliminate some options. Let us take the same example that we have considered, 57. Now 57 is ending in 7, hence it can be a prime number, okay? But it is not of the form of 6k plus or minus 1 because the next nearest multiple of 6 is 60. If we add 1, we'll get 61. If we subtract 1, we'll get 59. Hence it is clearly not of the form of 6k plus or minus 1. Hence it is not a prime number. So you don't really have to take the square root of 57, then check for divisibility by all the prime numbers less than that. You can straight away, by using these techniques, come to a conclusion if it is not a prime number. But if it is ending in 1, 3, 7 and 9, and if it is of the form of 6k plus or minus 1, then it may or may not be a prime number. For example, if we consider, let's say, the number 49. So it is ending in 9, hence we cannot say whether it is a prime number or not, and it is of the form of 6k plus 1, which is 48 plus 1. So hence we cannot directly straight away say that whether this number is a prime number or not. We'll have to take the square root, round it off to the next higher integer, and check for divisibility of this number by all the prime numbers lesser than that integer. I hope you are able to understand this concept of prime numbers. Let us now understand what is a twin prime number. If the difference between two prime numbers comes out to be equal to 2, then such a number is called as a twin prime number. Example, 13 and 11. These both these numbers are prime numbers. If we take the difference, it comes out to be 2. Hence, 13 and 11 are twin prime. Another example would be 43 and 41. The difference between them is 2, and such a number is called as a twin prime number. Let us now understand the concept of co-prime numbers. Any two numbers whose HCF is 1 are classified under co-prime numbers. Please note, it is not necessary that both the numbers should be prime number. Example, 9 and 16. If we find their HCF, this can be written as 3 square, this can be written as 2 raised to 4. Their HCF is 1. And both these numbers are not prime numbers, they are composite numbers. But still, since their HCF is coming out to be equal to 1, they will be classified under the category of co-prime numbers. So it is not necessary for two numbers to be co-prime, they should be individually prime. No, it is not necessary. So any two numbers whose HCF comes out to be 1 will be classified under co-prime numbers. Now there are certain rules that will help you in identifying whether a given set of numbers are co-prime or not. Two prime numbers are always co-prime numbers. In fact, any set of prime numbers will be always co-prime with each other. 2, 3, 5, 7, 11. If you take their HCF, it will always come out to be 1, since all these are prime numbers. Hence, they will be classified under co-prime numbers. Even two consecutive natural numbers, 2, 3, 9, 10, 99, 100, their HCF will always come out to be equal to 1. Hence, it will be classified under co-prime numbers. Then, three consecutive natural numbers with the first number as odd, 3, 4, then 5, their HCF will also come out to be equal to 1. Hence, they will be classified under co-prime numbers. So, these are the certain techniques that you can use for identifying two co-prime numbers. Remember, their HCF will always be equal to 1. So, this is all about numbers. Thank you.